In this lesson of 7.1.5, we're going to use our knowledge of similar triangles to prove two theorems. Okay, and so if you need some extra help, go ahead and click on the video first on our three theorems: the side similarity, side angle side similarity, and angle similarity. Okay, but if you feel confident with those, let's move on. All right, so here's our first problem. Okay, it's called the triangle mid-segment theorem. All right, so Sergio remembers the triangle mid-segment theorem from a previous course. Now that he knows about similar triangles, he wonders if he can prove the triangle mid-segment theorem using similar triangles. Okay, so we have talked about this question before. Okay, so we want to examine our lovely triangle. So A, B, C. We want to talk about D. So DE is called the mid-segment of the triangle because it connects the midpoints of the two sides. So again, notice that we have one little tick mark here, one little tick mark here. So we know that these two sides are equal to each other. Two tick marks, two tick marks. So again, these two sides are equal to each other. We had done this theorem where we actually had graphed this onto graph paper, if you remember. All right, so we examined it. DE is called the mid-segment. It connects the 2 points. So how do you think the mid-segment, DE, is related to AB? So hopefully you remember that AB's line segment is parallel to the DE's line segment. Okay, and again, we graphed it on a nice little grid where we did something like this, and we found the midpoint, and so we found that this slope and this slope were exactly the same. We also discovered, remember that AB, it looks like it was double the length of DE, so we can kind of say that AB's is equal to 2 times DE, or half of AB is DE. Either one. Okay, so again, that's just how they are related from previous courses. So let's write a conjecture, right? So write a conjecture about the relationship between DE and AB. So again, this is exactly what we just said. We could just say that AB is parallel to DE. That's one that we can do, right? Or we can do that AB is equal to the 2DE. Those are our two conjectures. We've already proven it before, graphing it onto graph paper, but now we want to use our flowcharts or a 2-column proof to help us. So Sergio wants to prove this guy. AB is double of what DE is. However, he does not see any congruent triangles in this diagram. So we want to know, how are the triangles in his diagram related? How do you know? Prove your conclusion with triangles with either a flowchart or 2-column proof. Okay, so what do we know? Okay, so we have 2 triangles. So let's make sure that we understand our 2 triangles. We have one triangle that is a C, D, and E. And we have another triangle, which is your C, A, and B. Okay, and so basically what we want to do is we want to see if these two are congruent, or sorry, not congruent, are similar to each other. Okay, now we don't actually know this side right here, so we only actually know one angle in common. So we know that C is going to be in common with both of them. So if we think back to our 3 similar triangles theorems, we know it's not going to be SSS. And looking at these, I don't see another angle in common, so I know that I can't use AA. So what I want to do is I want to use SAS. And remember, similarities have similar proportions. So the proportions have to be equal to each other. So that's the one that we're going to use. Okay. So let's go ahead and let's do a 2-column proof, since we were having some practice with a 2-column proof earlier. So we have statements and we have reasons. Okay, so let's start off with what we actually know. We know that angle C is equal to angle C. So I'm going to say for my first statement that angle C is congruent to angle C. And why? It's the reflexive property. Okay, or we could say angle is congruent to self. Okay, what do I know? I know that CD is equal, right, to DA, and all of this, right, so let's think about what we know. So we know that CD is equal to AD, right? We also know that AC is equal to AD plus CD, okay? AD plus CD. So that kind of is given information. Let's actually put that into our flow chart. So I'm going to put those together. So CD is equal to AD, and AC was equal to AD plus CD. That was given information. We can also, let's figure out how we can use that information. Okay, so if I think about this, let's replace something. So I'm going to replace CD in for right there. So then this becomes AC or CA. Again, it doesn't really matter how we write this. So then CD plus CD. So I have two of them. So I have two CDs to listen to. So if I divide this by 2, I know the ratio of AC over CD. Let's flip these so that means the C is together. Is going to be 2. So I'm going to say that CA over CD's proportion is 2, and I just did substitution. I did a little bit of math. Okay, so now let's see if this is the same thing. Okay, so let's go ahead and I'm going to do exactly what I just did right here. Instead of CD, I'm going to say that CE is equal to EB, and also that CB is equal to CE plus EB. So again, if I replace CE with EB or vice versa, EB with CE, again, this is given information. Basically, what's going to happen is I'm going to have CB equal to CE plus CE, right? And again, this will be 2 CEs. If I divide that, CB over CE will equal 2. So again, I'm going to put that right here. So CB over CE equal to 2. Substitution. So basically what I just found is I don't actually know what these lengths are, right? I have no idea what this length is, but I know if I take this length and I divide it by CE, and I take this length and I divide it by CD, these two proportions are going to be equal to each other. So essentially what I just found is here's my angle, this part is my side, right? This is my other side. So we've just proven that these two triangles are similar. So we're going to say our triangle DCE, so our smaller triangle, is similar to triangle ACB. And again, remember the letters do match up. So now they are similar to each other. So that's exciting. That's exciting stuff, right? So we've just proven, right? However, he does not see congruent triangles. So how are these triangles related? So we've just proven how they're related. They are proven through side angle side similarities. Okay. So let's continue. Let's look to see kind of what else. So what is the ratio between the corresponding side lengths to the similar? Use this to write a statement relating the lengths of DE and AB. Okay, So what do we know? We know based on this ratio, CA, like the larger side over the smaller length is always equal to 2. We know CB, which is the larger side, over CE is also equal to 2, which means that my AB is my larger side and DE is my smaller side. So basically I'm going to say that AB over DE is equal to 2. And again, it's based on our ratios, right? All of our ratios have to be the same. So again, here is our A, C, B, D, and E. So again, larger over the smaller one. Okay. Okay, so now he wants to prove that DE is parallel to AB. So is DE parallel to AB? So if these are parallel to each other, right, all of our angles should be similar, which means that since this is in common, okay, and if I break it up into, again, my two triangles, right, so D, C, E, and A, C, B, I know that this angle will match up perfectly with this angle. I'll also know that D should match up perfectly with A. Let's do 2. And then I also know that E would match up with B. So what I can do is let's do a flow chart this time. So let's just say that our triangle, so since we already know that DCE is similar to triangle ACB, right? Why do I get to say this? Previous proof. So that's the reason. I don't have to go back. And then what do I get to say? I get to say that angle CDE, so let's say CDE is going to be congruent, because they are exactly the same, to CAB. Why do I get to say this? I get to say this because similar triangles have angles that are congruent, right? The sides are not congruent, but angles are always congruent. So if these are congruent, right, these are corresponding angles. And corresponding angles are always congruent when your lines are parallel. So, and I only have to prove one angle. I don't need to write the other angles. So now I get to say that DE is parallel to AB. Bam. And they are corresponding angles. Okay. And that we have proven another way of why these two triangles, now the DE is half of the length of AB, or AB is double of what DE is, and also these two lines have to be parallel. All right, in our next video, in part 2, what we're going to talk about is Pythagorean theorem using similarity.